Welcome to Mathematics Online Lecture Series by Professor K. Narasimhan, Vector Calculus, Lecture number 28, Vector Integration, 6th lecture. Today's topic is Surface Integrals. Now, we will discuss very important question in surface integrals. What is the question? Evaluate integral f dot n ds if f equals to 2x square yi minus y square j plus 4xz square k, and S is the closed surface of the region in the first octant bounded by the cylinder y square plus z square equals to 9, and the planes x equals to 0, x equals to 2, y equals to 0, y equals to 2. Now, what is the diagram? First, what is the cylinder diagram? Just I will draw cylinder diagram. Okay. 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 This is x-axis, so this is y-axis, z-axis and x-axis. Now, y square plus z square represents a circle in yz plane, and x is 0 to, given x is 0 to x is 0 to 2 is given. So, lower part is x equals to 0 and upper part is x equals to 2. But, and also this cylinder is given in first octant. Now, this is very important point. Our region in first octant is nothing but the region between xy plane, yz plane and zx plane. Then what is the actual diagram? Okay. Sorry. What is the actual diagram? Okay. Now, I will take so this is y, I will take z axis and this is x axis. Okay. So, in the xz plane it is a rectangle, and so in xy plane it is also a rectangle. Fine. Now, this is the circular plane. So, if you observe, the given question is a closed surface. Closed surface means we have total 5 surfaces are there. What are the first one is a rectangle in xz plane, and the second surface is rectangle in xz plane, xy plane, and bottom is circular region, 1/4 of the circular region, and the upper part, this is S4, this is S3 lower part, and then circular curve S5. circular curve S5. So we have total 5 surfaces. Now we will evaluate the surface integral over S1, over S2, over S3 and also over S4. Okay, one by one. First, over the surface S1, which is shown in the figure. Now what is N? First, what is N in S1? Outside normal. Outside normal is N equals to, normal is y-axis minus y-axis, its normal is minus j. And also, if you observe, in xz plane, y equals to 0. Now it is a rectangle, so whose side is, okay, this length, nothing but the radius is 3, 0 to 3, and z is also 0 to 3. Sorry, z equals to, x is 0 to 2, which is given upper part, this length. Now this length is, radius is nothing but 0 to 3. Okay, y equals to 0. Now what about f dot n? F is known, f is the known function, dot product with minus j, nothing but minus y square, minus or minus plus y square. Already y is 0, so integral f dot n ds over the surface S1 equals to 0. Now first surface is 0. Now second, over the surface S2. Rectangle in xy plane, rectangle in xy plane, what is the outside normal? Outside normal is, here outside normal is minus k, n equals to minus k. Yes. Now what about x, y, z? In xy plane, z equals to 0. Now this is a rectangle in xy plane. Okay. If you want, I will insert the color just for understanding. I will insert the color. Wait. Just for understanding. No. Okay, very difficult. Okay, I will draw with red color. This rectangle. Okay. Now coming to x. Along x-axis is 0 to 2, already given, directly given, 0 to 2. Y. Along y-axis, here this point, this one, this is nothing but radius of the cylinder, a circle, then no problem, 0 to 3. So n equals, z equals to 0. Now what about f dot n? F dot n equals to, kth quotient is 4xz square, 4xz square. Already z is 0, so integral value f dot n is 0, integral f dot n ds over the surface equals to 0. Okay, fine. Now coming to third, over the surface S3. Now what is S3? S3 is this region. Now this region is here x equals to 0. Here x equals to 0, n outside normal is minus I. N equals to minus I, x equals to 0. Okay, then we will discuss later remaining. F dot n. If it required, we will find the limits of y and z. F dot n is 2x square y. 2x square y. X is already 0, so not required. No need to find the y limits also. Nothing but circular y. Suppose if you want y and z, find out the y square plus z square equals to 9. Then y limit 0 to root over 9 minus z square, then 0 to 3. Actually, but not required here. No need to find. Integral f dot n ds over the surface S3 equals to 0. Okay, fine. Fourth one. Over the surface, yes. What is n? I will take different color for identification. Okay, this circular part. So here outside normal is n equals to I. Okay, back. N equals to I. X is at that point, this circle is nothing but x equals to 2. X equals to 2. X equals to 2 and y limits already discussed, 0 to 9 minus z square and z is 0 to 3. Sorry, 0 to 3. Now what is f dot n? F dot n equals to, so this is same as here negative sign, no negative sign here. F dot n. Okay, fine. X equals to 2, that is 8y. Integral f dot n ds over the surface S4 equals to double integral of f dot n is 8 into y. Here varying variables are y and z, dy, dz. Okay, and y limits 0 to square root of 9 minus z square. X is 0 to 3. Sorry, z is 0 to 3. First integrate with respect to y, then integrate with respect to z. 8 into z is 0 to 3. Integral y equals to y square by 2. 0 to root over 9 minus z square dz. So this is 4 into x is 0 to 3, 9 minus z square. Integration 9z z cube by 3, 0 to 3. Now substitution 27 minus 9 into 4 times here, 4 times is also there. So 4 into 18 72. So this integral is integral f dot n ds over the surface S4 equals to 72. Now fifth surface. Now this is most important one. Fifth surface over the surface S5. This is nothing but the S5 surface is nothing but cylindrical surface. This curved surface. This curved surface, I will take another color just for understanding. I will take green color. So this one, 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 this one. Okay. First we will find the unit normal. Then how to find n equals to del phi by mod del phi. So using this formula we will find the unit normal to the surface. Okay. Here n equals to del phi by mod del phi. What is phi? Let phi equals to cylinder x y square plus z square minus 9. Del phi equals to I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. Okay. Then how to find the value? 2yj plus 2zk. N equals to del phi by mod del phi. 2 times of yj plus zk by 2 times of y square plus z square. So 2 cancel, yj plus zk by y square plus z square equals to 9, under the root is 3. Now what is f dot n? F is already known. I will write directly. F equals to 2x square y minus y square j plus 4x z square k. So dot product with n. So jth quotient is minus y cube and 4x z cube. 4x z square into z is z cube by 3. Okay, minus y cube plus 4x z cube by k. Okay, fine. Now after finding n and f dot n projection, if S is projection on which plane? Now this is very, very important. We cannot project on a yz plane, we can project on either in xz plane or xz plane. So I will take xy plane. If S is projection, S phi, Sy is projection on xy plane, then ds equals to dx dy by modulus of n dot k. So k is n is already known, z by 3. N dot k equals to z by 3. Okay, now integration. Now integral f dot n ds over the surface S3 equals to double integral of minus y cube plus 4x z square z cube by 3 into dx dy by z by 3. Okay, fine. Over the surface S3. Now integration, simplification. So what about the z quantity? Z quantity is y, given curve is y square plus z square equals to 9. From this one z equals to root over 9 minus y square. Okay, I will rewrite the terms in place of z. Here 3 and 3 cancel. Double integral of minus y cube by z. Z is nothing but root over 9 minus y square plus 4x into z cube by z, z square. Z square equals to 9 minus y square. Okay, dz dy. First I will write the z limits, then I will write the y limits. Okay, because z integration is 0. Here integration with respect to x, with respect to x and y. First integrate with respect to x, then integrate with respect to y. First x, integration with respect to x and y. I will add this. Here integration with respect to x and y. Very simple here, calculation is very simple. I will write here minus y cube by z plus 4x z cube by z. Here z cancel, here you will get 4x z square. Z square is nothing but 9 minus y square, here z is nothing but root over this one. First I will write the x limits. X limits are directly given 0 to 2. X limits are directly given 0 to 2. Now, x is 0 to this one 2. Y limits. Now, y limits. So, in this equation, I will write here y square plus z square equals to 9. In xy plane, z coordinate is 0. So, y equals to 3. So, in first octane, initial value is 0, 0 to 3. Now, integrate with respect to x. Y is 0 to 3. Here there is no x term. Minus y cube by root over 9 minus y square into x. Here 4x square by 2, 9 minus y square. X limit 0 to 2 dy. Okay. Now simplification. X equals to 2, you will get 2 here. Here y is 0 to 3 minus 2y cube by root over 9 minus y square. Dy is the first term. Second term is here 4, 16 by 2 is 8. Y is 0 to 3, 9 minus y square dy. Now second part integration is very simple. For first part integration, put y equals to 3 sin theta. Dy equals to 3 cos theta d theta. So theta limit 0 to, if you put y equals to 0, sin theta is 0, y equals to 3, sin 3 theta is 1, so theta to pi by 2. Now second part is very simple. Okay, one more. Okay, now integration. First part integration equals to theta is 0 to pi by 2 minus 2 here. Y cube is 27 sin cube theta by 9 minus y square is nothing but 9, I will write here 9 minus 9 sin square theta, 9 into 1 minus sin square theta, 9 into cos square theta. Under the root is 3 cos theta. Here dy is 3 cos theta. Okay, we will write later. Here 3 cos theta cancel. So 54 into theta is 0 to pi by 2. Now sin cube theta. What about sin cube theta? What is sin cube theta? What is sin 3 theta? Sin 3 theta formula. Okay, I will write here. Okay, I will write here. Sin 3 theta equals to 3 sin theta minus 4 sin cube theta. From this one, sin cube theta equals to sin 3 theta, 3 sin theta minus sin 3 theta by 4. Now substitute this quantity in the above integral. This is minus 54 into theta is 0 to pi by 2, 3 sin theta minus sin 3 theta by 4 d theta. Okay, plus another term is there, we will discuss later. Minus 54 by 4 into sin 3 theta integration is minus 3 cos theta. Sin 3 theta integration is cos 3 theta minus or minus plus cos theta by 3, 0 to pi by 2. Now what about the simplification? Okay. Minus 54 by 4 into, if you put theta equals to pi by 2, cos pi by 2 is 0, this is also 0. If you put theta equals to 0, minus or minus plus 3, minus 1 by 3. So minus minus 54 by 4, 8 by 3. 8 by 3. Minus 72. Okay. Let us, we will discuss the remaining part. Here, second part integration, 8 into 9y minus y cube by 3, 0 to 3. Very simple. 8 into 27 minus 27 by 3 is 9. 8 into 18. 8 into 18. 18 into 8 is nothing but 144. 144. 144. 144. 144. 144 minus 72 is not. 72. Okay, I will check it. Okay, here a small calculation error. This is not. This is. Okay, I will write here. 6 nines are 54. Okay, small mistake, calculation error here. This is 6 times minus 48. So 108 is the answer. Therefore, integral f dot n ds over the surface S5 equals to 108. Finally, hence integral f dot n ds over the surface S equals to first S1 plus S2 value plus S3 value S4 value, S5 value. First three values are zeros, then 72, then 108. Finally, 108. Integral f dot n ds over the surface S equals to 108 is the answer. Very simple, but try it. Okay. In the next class, we will discuss about the